Okay, friends, I am, oh God, I just put the dot plot there. What? Okay, here it is. Here's my dot plot. All right, I am back with a separate video because I completely and utterly forgot to press record, and I already did the whole thing, and then, but anyway, we're here now. We're here now, and it's okay. So, what does each dot represent? Well, this time, instead of the number of orange candies, this time it's the proportion of orange candies from our sample. The proportion of orange candies in each sample. Okay, the new mean and the new standard deviation. Well, our new mean, our old mean was just 20, right? So 20 out of 50 is 0.4. These are all the same counts, right? This is still 15 candies or whatever, but it's 15 out of 50 now. So for each one of these, I divided by 50. So for my new mean and new standard deviation, I'm just going to divide by 50. So this is the mean of my proportion. Then over here, I'm going to have the standard deviation of my proportion. Same thing, going to take my one from before, 3.3, and divide it by 50. So that one I got to get out my calculator for. Okay, and I'm going to get 0.066. So the approximate shape of my sampling distribution, well, it looks kind of like, well, okay, hopefully your drawing's better than mine. But we're going to call it approximately normal. And adding more samples would make it more normal. Okay, now, in a bag of Reese's Pieces, so in our total population, we have exactly 40% orange. If we select 50 random candies, what is the probability that the sample proportion will be 50% or greater? So in our sample, what's the likelihood? We have 50% or greater. So here's our normal distribution. Here is our sample mean. I'm sorry, not our sample mean. Here's our population mean of 0.4. And here is our mean that we're going to look at of 0.5. And we want to know any of these are fair game, right? It's not just 50, it's 50 or more. So any of these are fair game. So we can think way back to when we studied normal distributions, and we can say, well, we can use a z-score to figure out this percentage. So our z-score is equal to the proportion that I'm looking at minus the true population mean divided by the standard deviation. So that would be 0.5 minus 0.4 divided by 0.066. And I put that in my calculator, and I get a z-score of 1.515, which is really 1.52. And then I have to go to my z-table. Okay, where's my z-table? Okay, here's my z-table. So I have 1.5012, 1.52, 0.93574. So I'll come back over here. I'm going to say 0.93574. This means that 93.574% is to the left. We don't want that. We want what's to the right. So I need to do 1 minus this z-score. So I'm going to do 1 minus 0.93574. Okay. 0.93574. And I'm going to get 0.06426. So that means about 6%. There's a chance there's about a 6% chance that my sample will have 50% or more candies, because there was not a lot of standard deviation. Okay, so we have some important ideas. So I'm going to scroll over here to do our important ideas. We're going to need a pen. Okay. For in our important ideas, my mean and standard deviation, the mean of my proportion is going to be P, while my standard deviation is going to be P minus, nope, okay. It's going to be square root of P1 minus P over N. This is my mean and standard deviation of a sampling distribution. Now, we kept saying that it was approximately normal and it would get more normal as we got more samples. Well, so the idea of normalcy. We need large counts here. N times P should be greater than or equal to 10. N times 1 minus P should be greater than 1 minus P, should be greater than or equal to 10. That's a quick way to tell if you have enough samples. So if I did 25 samples times 0.4, I would get exactly 10. So mine was barely big enough. Bigger is better. Okay, so our last big idea is finding probability. So if our sampling distribution of P hat is approximately normal, so if what we're dealing with is approximately normal, we can use our z-scores. And that was equal to P hat, what we were looking for, minus our true proportion divided by our standard deviation, which we saw in our last big idea. P times 1 minus P over N. So these are on your equation sheet. And finally, I want you to notice that for our binary distribution, the last unit, where's my thingy? Still can't spell distribution. Okay, this was all dealing with counts. 20 orange candies, 16 orange candies, whatever. My sampling distribution is going to deal more often with statistics and proportions. And that is 7.2.